Hi, so for today we're going to talk about rules for finding the derivative. So we have rules for finding the derivative. So for our number one rule is the derivative of constant. So always keep in mind that the derivative of constant is always equal to 0. So it means if you have a y that is equal to 3, if we get the derivative of that, dy over dx, the derivative of y with respect to x, is always equal to 0. So here is the formula. D over dx of any constant c is actually equal to 0. Okay? So if you are asked to find the derivative of, for example, let's say again, y is equals to 1000, the derivative of y with respect to x is always equal to 0. Okay? So, for our number 2 rule is what we call the power rule. So, the power rule has this formula dy, d over dx of x raised to any number, diba? N, then it is actually equal to n times x raised to n minus 1. Okay? That is, we're going to get the power, then multiply it to our original x, but we're going to subtract 1 from its original exponent. So let's say, for example, we have y is equals to x cubed. Okay? If we're going to get the derivative of y with respect to x, we get the exponent 3, then multiply it by the function x cubed, but we have to apply minus 1 because the formula says n times x raised to n minus 1. So that we have this 3x raised to 3 minus 1 is actually 3x squared. And we now get the derivative of this function y is equals to x cubed. So another example is, for example, we have a function that has x raised to the fifth. Okay, so we have dy over dx is equals to 5 times x raised to 5 minus 1, or in other words, simplifying this, 5x times x raised to the fourth. Okay, so very simple formula. Okay, the power rule. For our third is the derivative of a constant times a function times a function. So it says here the formula dy over dx is actually equal to d over dx of the function constant times a certain f of x. So we have here, since the derivative of constant is, we have to, since this is constant c, we can actually isolate that and get the derivative of that f of x. Okay, so for example, we have here an example. So for example, find the derivative of y is equals to 3 times x raised to 6. So this is our constant 3. So all we have to do to find the derivative of that is to apply that formula. So what are we going to do? Is 3 times dy over dx of x raised to 6. Okay? So in order to get that, we have 3, apply our formula, 6 times x raised to 6, oops, x raised to 6 minus 1. So we have applied the power formula. So to simplify, we have 3 times 6, that is 18. X raised to 6 minus 1 is 18 times x raised to 5. So if we have a constant, simply we're going to get the derivative of this function and isolate this constant. Okay, so another example is this. For example, we have here y is equals to 2x squared. Okay, in order to get the derivative of this, we have to leave the constant itself and get the derivative of the function x squared. So we have here 2 times the derivative of x squared. By power formula, we get the exponent, we multiply it, and then the original function, x raised to 2 minus 1, that will be equal to 2 times 2, that is 4, times x. 2 minus 1 is x raised to 1, or in other words, x, so that we have the answer 4x. Okay, so how about the fourth rule? The derivative of sum and difference. So in this case, we shall be applying the formula dy over dx is equals to d over dx times u plus or minus v, and that is equal to the du over dx plus or minus dv over dx, wherein u and v are two terms. Okay, so for example, we have here this y is equals to 3x squared plus 2x minus 1, and find the dy over dx of that function. So in order to get the dy over dx, or the derivative of this function y, we have to evaluate the individual derivatives of this function. So we have the first term, that is the derivative of a constant 3 times a function x squared, and also for the second term, that is the derivative of a function times a constant, a function x, and a constant 2. And in this third term, that is simply the derivative of a constant. So if you wish to get the derivative of that, so we have 3 times, we're going to get d over dx of x squared plus 2, the derivative of the function x, minus the derivative of the constant 1. So we're going to get that 3, and by power rule, this is times 2 times x raised to 2 minus 1, and plus 2, that is times 1 because the exponent of this x is 1. So, and times x raised to 1, 1 minus 1, minus the derivative of constant is again 0. So we have here 3 times 2, that is 6. X raised to 2 minus 1, that is simply x, plus 2 times 1. This x raised to 1 minus 1 is x raised to 0, that is 1. So simply 2 times 1 times 1, that is 2. So we have now the derivative of this function. So another one, how about if we have this? So we have y is equals to 2/3 of x cubed minus 4x plus 86. So same formula, same approach. We have to get dy over dx. This is a constant and a function. This is a constant again and a function. So we have to get 2/3 the derivative of x cubed minus 4 times the derivative of this function x plus d over dx of this a to 6 constant. So 2/3, bring down 3 because that is the exponent, multiply it, then x cubed minus 1, so power rule again. So minus 4, the derivative of this x is simply 1. Okay, if we're going to evaluate it again. Okay, so plus the derivative of this constant, again, the derivative of constant is, yes, you are right, that is 0. So as you can see here, 2/3 times 3, simply the 3 will cancel, and then we will be having 2 times x raised to 3 minus 1, that is x squared minus 4. And that shall be our answer. Okay, so the fifth rule is the derivative of a product. So it says here that our formula is dy over dx. We wish to find the derivative of product d over dx of u times v, where u and v are both function. So we have to apply this formula. U is times the dv over dx plus the v du over dx. Okay, so we have this u and v. So first we have to get, or to copy first, the function u, then let's try the derivative x, that will be our first term, plus copy v, then we're going to get the derivative of u with respect to x. So one example is this, okay, is x plus 1 times x plus 2. Okay, we can use FOIL in order to get this, to perform this product, but using this derivative of a product, we can simply use the formula, let's say dy over dx. So what are we going to do is, this will be our u and this will be our v. So it says in the formula we need to copy the first one, x plus 1. Then we're going to get the derivative of the second one, x plus 2, plus copy the v. This is our v, x plus 2. Then we're going to get the derivative of the u, which is actually x plus 1. So in other words, copy the this first, and then get the derivative of this, multiply it. That's your first term. Okay, plus copy the second term, and then what we're going to do is multiply it by the derivative of the first. So in this one we have x plus 1, and the derivative of this is actually what? The derivative of x is 1, and the derivative of constant is actually 0. So plus x plus 2, the derivative of x is actually 1, and the derivative of 1 is actually, oops, I'm sorry, I need to erase this. Okay, then the derivative of 1, or this 1, is actually 0. So that is a constant. So again, we get the derivative of x, which is equal to 1, get the derivative of 1, which is equal to 0. So simplifying, we have x plus 1, simply this will be multiplied to 1 because 0 have nothing to do with that. So x plus 1 plus, simply x plus 2 is multiplied to 1, so we will be having x plus 2 here. So to simplify that, we have x plus 1 plus x plus 2. So we have the answer, combined like terms, x plus x, that is 2x, plus 1 plus 2, that is equal to 3. So another way to get this is what I'm telling you a while ago, is to get the product of this using the FOIL method. Okay? So if we're going to get the derivative of that, we simplify that first. So into a single function, we multiply this 2. So what are we going to have is the FOIL. Apply the FOIL method first. X times x, that is equal to x squared. Outer x times 2, that is plus 2x. And our inner is 1 times x, that is equal to x. And last, 1 times 2, that is plus 2. Then we're going to get the derivative of this. So if you get the derivative of this, dy over dx, so we apply the power formula here. So 2x plus 2, okay, plus 1. Why? Power formula for here, x squared, 2x. Then this is the derivative of a constant times a function x. So derivative of constant, we're going to get it out of the derivative. Then derivative, the function x will result to 2. And the derivative of this x is 1. Plus the derivative of this 2 is actually a constant that is equal to 0. To simplify, we have now the answer. Simply 2x plus 2 plus 1 is actually equal to 2x plus 3, which is the same as this. Okay, but sometimes there will be a given function in terms of y that is really hard to multiply, or really, I would say, time consuming. So you would really want to use this product rule, okay, rather than getting first the product, then apply this formula of power rule and the derivative of a constant times a function. So let's try another formula. We have y is equals to x cubed plus 2x times 2x minus 1. So if we're going to get a derivative of this, y prime, that is equivalent also to dy over dx. Simply, this is our u, this is our v. So simply copy the u first, or the first term, x cubed plus 2x times the d over dx of 2x minus 1, that is the derivative of the second, plus copy the second, which is 2x minus 1. Then we're going to get the derivative of u, or the first. Okay, so we have x cubed plus 2x. So here we go. So we have x cubed plus 2x times the derivative of 2x is actually what? It is equal to 2. Okay? And the derivative of this negative 1 or minus 1, since that is a constant, that is minus 0. Plus 2x minus 1 times the derivative of this. So we can apply power formula in this one. So we'll be having 3x squared plus 2. Okay? So the derivative of this is actually 2, because this is a function x multiplied by constant. The derivative of this is 1. 2 times 1, that is equivalent to 2. And this is a product, power rule, I mean. Okay? So simplifying our answer, we have x cubed plus 2x times 2 plus 2x minus 1 times 3x squared plus 2. Okay? So in order for us to find that, so we're going to simplify 2x cubed plus 2 times 2x, that is 4x, plus we're going to find the FOIL of this. Okay, so first 2x times 3x squared, that is 6x cubed. Outer 2x times 2, that is equal to 4x. Inner negative 1 times 3x squared, that is negative 3x squared. Then finally, last term, negative 1 times 2, that is equivalent to minus 2. So combining like terms, so we have here 2x cubed plus 6x cubed, that is simply 8x cubed. So we have a second degree here, so we can write it here. So another one, 4x plus 4x, again we're combining like terms here. 4x plus 4x, that is 8x. And then finally, the constant term is minus 2. So our answer should be 8x cubed minus 3x squared plus 8x minus 2. Okay, this shall be our answer. So another one, for product rule, we have here the given x cubed minus 3x squared multiplied by x squared plus 4x plus 2. So same concept, we will apply the product rule here. So again, copy first the first, that shall be our u, and this shall be our v. First term minus 3x squared times, we're going to get the derivative with respect to x of the v, which is x squared plus 4x plus 2, plus copy the v, or the second term, plus 4x plus 2. Then we're going to get the derivative of x cubed minus 3x squared. That is the derivative of the first. So in this case, we should copy only here. Then we're going to get the derivative of this. This is a combination of a product or a power rule, and this is a derivative of constant times a function, and this is a derivative of a constant. So the derivative of x squared is simply, by power rule, 2x, and the derivative of 4x is simply 4, and the derivative of this constant 2 is actually equal to 0. So plus x squared plus 4x plus 2 times the derivative of this, since this is a power rule, so 3x squared. Yes, you got it right. So minus, this is a combination of power rule and a constant. So we have 3 times 2, because of power rule, 6 x raised to 2 minus 1. So we will be having 6x. Okay? So to simplify, x cubed minus 3x squared, we have 2x plus 4. And then for this, we have x squared plus 4x plus 2 times 3x squared, 3x squared minus 6x. So in order to simplify, we need to apply FOIL. First, x cubed times 2x, that is equivalent to 2x raised to 4. Outer, x cubed times 4, that is plus 4x cubed. Inner, negative 3x squared times 2x, that is equivalent to negative 6x cubed. And last, negative 3x squared times 4, that is minus 12x squared. So it gets the computation gets long. Okay, so plus, that is actually FOIL, or not FOIL, but simply the normal computation for product of these two functions. So we have 3x squared times x squared, that is 3x raised to 4, and 3x squared times 4x, that is plus 12x cubed. So 3x squared times 2, that is plus 6x squared. Okay? Then negative 6x times x squared, that is equivalent to negative x raised to 3. So negative 6x times 4x, that is negative 24x squared. And lastly, negative 6x times 2, that is negative 12x. So to simplify, we're going to combine like terms. Okay? So we have first the highest exponent. We can get it here. So this is the highest exponent. So 3x raised to 4. So next is we have raised to 4. That is, oh, my mistake. So that should be, no, we are wrong. This should be, we can simplify 2x raised to 4, then plus 3x raised to 4. That is equivalent to 5x raised to 4. Then we have here cube plus 4x cubed minus 6x cubed, that is negative 2x cubed, plus 12x cubed, that is 10x cubed, minus 6x cubed, that is plus 4x cubed. Okay, and for our x squared, negative 12x squared plus 6x squared, that is equivalent to negative 6x squared, minus 24x squared, negative 6x squared minus 24x squared, that yields to negative 30x squared. And finally, for our x, so we should copy because we don't have anything to simplify with x. So this should be our final answer. Okay, so let's go now to our rule. So our last rule for this video is actually the derivative of a quotient. So this will be our formula for that. Dy over dx is equal to the derivative with respect to f of a function that is in quotient form is equals to v times du over dx minus u times dv over dx all over by v squared. Okay, so this will be our formula wherein we have the numerator u and the denominator v. So what are we going to do first is that we're going to get first the denominator, then multiply it to the derivative of the numerator minus the numerator multiplied by the derivative of the denominator dv over dx all over, we're going to square the denominator. Or in other words, that is, we have a mnemonic for that. Low derivative of high minus high derivative of low divided by low, which is the denominator, squared. So let's try some problems. So for example, we have x, y is equals to x over x plus 1. So it is obvious that our u here is the x and our v here is the denominator, which is x plus 1. So in order to get a derivative of our function, so we're going to apply this formula or simply this. So what is that? Low, the denominator, times the derivative of the high, which is actually the numerator, minus copy the high, which is the numerator, times derivative of low, which is x plus 1, divided by low squared, which is x plus 1 squared. So let's recap. So we have here low, which is the denominator, low times the derivative of high, minus high, which is the numerator, times the derivative of low. So divided by the low squared or the b squared, the denominator raised to 2. Okay? So, low, derivative ng high, high, derivative of low, divided by x plus 1 squared. So, we shall have the answer x plus 1 times the derivative of x, which is simply 1, minus x times the derivative of x is 1, plus the derivative of 1 is 0, divided by x plus 1 squared. So we have the answer, x plus 1 times 1, which is simply x plus 1, minus x times 1, which is x, divided by x plus 1 squared. To simplify, x will cancel, x minus x, so we are left with 1 over x plus 1 squared. So this will be our answer. Okay? So another problem, derivative of a quotient, we have 2x x squared plus 1. So again, we will be applying the low, the high. I suggest you memorize this. Low d high minus high d low divided by low squared. Okay? So first, we need to get the low, which is the denominator, x squared plus 1. Multiply it by the derivative of the high, d over dx of 2x minus high, which is 2x, times the derivative of low, d over dx x squared plus 1 divided by low squared, x squared plus 1 raised to 2. So we have here x squared plus 1 times the derivative of 2x is simply 2 minus 2x, the derivative of this, we need to evaluate first this. X squared is 2x plus the derivative of the constant is 0. So divided by still x squared plus 1 squared. So we have now x squared plus 1 times 2, that is 2x squared plus 2 minus 2x times 2x, that is 4x squared divided by x squared plus 1 squared. So we have now the answer, 2x squared minus 4x squared, that is negative 2x squared plus 2 divided by x squared plus 1 squared. Okay, so we can simplify this further by factoring out 2. So we have 1 minus x squared divided by x squared plus 1 squared. So this shall be our answer. If you find this video helpful, don't forget to click like and subscribe to my channel. Thank you so much for listening, and God bless you.